our last theorem is the triangle angle bisector theorem. It's kind of a unique theorem. And it says this: if you draw the angle bisector in, it's going to split the opposite side of that angle into the same proportion as the length of the other two sides of the triangle. So let's apply that to a problem here. So here I've got an angle bisector, and I want to find the value of x. So I've got an angle bisector, so it splits the sides. X is to 6 in the same proportion as the other two lengths, as 15 is to 9. Well, I notice 15 and 9 can be reduced. I'm going to divide both of those by 3, so I get x is to 6 as 5 is to 3. Then notice if I take 3 times 2, I get 6. If I take 5 times 2, x equals 10. You can solve that in a number of different ways. Now, be careful. Sometimes, let me make up a different problem here. Let's say we have an angle bisector. And let's say, instead of giving you the length of one side, let's say I say this whole length along the bottom is y. And let's say this is 5. And then I'll say my other two sides will say, I'll go 7 and 4. Now, what you want to do is you want to come up with an expression for my missing side. My missing side, this part right here, is going to be the whole length minus 5. So it'll be y minus 5. So that's just your segment addition theorem again. So let's do this problem. So I'm going to say y minus 5 is to 5 as 7 is to 4. Then what I'm going to do, I'm going to solve for y. So I'm going to multiply both sides by 5. It doesn't reduce, so I get y minus 5 equals 35 over 4. Then to solve for y, I'm going to add 5 to both sides. Now I need a common denominator. So y equals 35 over 4 plus 20 over 4. Because 20 divided by 4 is 5. So in other words, y is 55 over 4.